Hello class. Before studying the criteria for a compound to absorb the ionization, we should know some basic terms. First, let's know that there are different types of energy associated with molecule. There are actually four types. So with these four types of energy, adding these four types of energy, that will give us the total energy occupied by a molecule, where electronic energy is the highest one, followed by vibrational energy, followed by rotational energy, followed by translation energy. And one more important point we should know is each and every molecules vibrates and rotates. Either it is oxygen, either it's nitrogen dioxide, either it's carbon dioxide or HCl, either it's polar compound or non-polar compound, any compound, they always keeps vibrating and rotating. They vibrates and rotates. Now, the next basic term we should know about is the dipole moment. What is this dipole moment? First, we should know what is this term dipole represent. Dipole means there is a one pole is there. Pole is there. Di means there are two different charges. Means two different charges at two end of the pole. Means at one end, if there is positive charge, then at another end there is a negative charge. This is known as dipole. Di means what? Two different charge at the two end of the pole. That is known as dipole. And these two charges are separated by some distance, and that gives us some strength of this dipole compound or dipole molecule. Okay, so that strength is known as a moment. That strength is known as moment, dipole moment. Okay, so it is represented by mu equals to r into q, where q is the any one charge and r is the distance by which these two atoms are separated. And this depends on these three things. First thing is what? For a dipole moment to occur, to find out the dipole moment or what is the dipole, two different charges should be separated. Okay, and they should be present at the two side of the pole. Second is on these two atom, on the two different end of the pole, these two atom, there should be some difference in electronegativity. Means the electronegativity must not be zero. There should be some electronegativity. Why? I will explain. Because if there is the difference like HCl, here chlorine electronegativity is more than the hydrogen, due to which they will try to pull the electron in this covalent bond towards itself, due to which this more shipment of the electrons will be more towards the chlorine, which will give them the partial negative charge. I'm not saying completely negative charge, okay, because still the electrons are in the bond and they are sharing between each other. That's why it's gaining the partial negative charge. So by default hydrogen will get the partial positive charge. So there is charge also, so you are getting the value q. They are separated by some distance, so that you have r also. So the strength, that is the dipole moment, will be never be zero. So they will have some dipole moment. So coming to the oxygen and the nitrogen, see, they are separated by some distance, so r is there, but at the both end, because of same atom, there is no electronegativity difference, due to which there is no pulling shipment of the electrons towards one end or the one atom, due to which there will be no development of positive and the negative charge. So due to the no charges, the q value will, there will be no q value, the q will be zero. So due to the q zero, the dipole moment will be zero. Same goes to the nitrogen dioxide. Now coming to the third point, they must have magnitude r into q. Like this is having r into q. They don't have mu because the charge is not there. They don't have mu because the charge is not there. And they must have direction. See here, they have some charge because oxygen is pulling the electrons towards itself, from the right side also, from the left side also. So they have the negative charge and positive charge in the carbon. Charge is there, distance is also there, r is also there. So why this dipole moment is zero is, means we should know dipole moment is a vector quantity. The dipole moment is a vector quantity, and they must have a particular direction. The overall molecule must have the particular direction. But see here, like in the SCl, the movement or the shipment of the electron is towards the chlorine, so there is some direction. But here, because of this movement of the shipment of the electrons towards right oxygen, the direction will be in the right side. Same way direction will be in the left side. So because this opposite direction, they will cancel each other, and the overall molecule have no direction. So the magnitude only will not be enough to determine, to define the dipole moment. There must be some direction also. So because of no direction, the carbon dioxide, that will say there is no dipole moment in the carbon dioxide. So for the dipole moment to occur, there must be the magnitude as well as direction. So now coming towards the third point, what we studied before, each and every molecule vibrates and rotates. So like either it is oxygen or nitrogen dioxide or HCl or carbon dioxide, each and every molecule, they vibrate and rotates continuously. So why they are vibrating, here we'll know. Suppose we'll take one polar compound which is having some dipole moment HCl. Because of the electronegativity difference or development of partial negative and positive charge and separated by some distance, so this polar compound we'll see here, suppose this is hydrogen and this is the chlorine with their electrons on the outermost shell. So what will happen now, the electron will pulled by the electron of hydrogen will be pulled by the proton of a chlorine. Similarly, the electron of chlorine will be pulled by the proton of a hydrogen. So there is attracting force or the attraction force between the electron and proton, due to which these two, hydrogen and chlorine, will come together. So bond length will be decreased. Listen carefully, the bond length will be decreased due to the attractive force. Now when they will come close together, the electron in the outermost shell, because of their negative charge, the negative charge will repel each other, due to which the hydrogen and chlorine, after coming close together, they, because of the repulsive force, they will now move apart from each other. They will now move apart from each other. So when will they move apart? Again, due to the attractive force between the electron and proton, they will again come near to each other. So continuously, due to the attractive and the repulsive force, there will be change in the bond length. There will be what? Change in the bond length. So due to the change in the bond length, the distance between the nucleus of these two, hydrogen and the chlorine, also changes continuously. So you have different r at the different time. You have different r at the different time. So due to the change in the r, your due to the change in the r, your dipole moment also what? Changes. Charge is same, but because of the change in the r, your dipole moment also changes. So what we come to know is, each and every molecule, due to their vibration, their dipole moment keeps on changing. Due to their vibration, their dipole moment keeps on changing. So now your question must be, in exam, in books, in a different reference book, we used to see the dipole moment of the SCl is fixed, like mu equals to some like 1.54 something. So what is this about? If it is continuously changing, then why we are writing 1.54? So why, what is that is, see, while stretching there will be some point. See, suppose it's coming near, so while moving apart, so there will be some point where the attractive force and the repulsive force will be equal. The attractive force and the repulsive force will be equal. So this is known as the equilibrium state. So at this equilibrium state of this molecule, the radius or the distance between the two nucleus at the equilibrium, okay, this r is taken to find out the dipole moment. So if you see a dipole moment of any compound, then we should come to know that this is the dipole moment at the equilibrium state of this molecule. That means equilibrium state means what? The moment where their attractive and the repulsive force is what? Same. Okay. So, and your question must be, suppose if it is stretching, and this is the point where, and this is the point at which they are equilibrium. If it is stretching, then why they don't stop here? Why they comes more near than the equilibrium? If here is the equal attractive and the repulsive force, why they are coming near? if here is the equilibrium. This because yeah, this is the good question. And why it's coming near is, so if it is stretching and it's coming back to the equilibrium, due to the inertia of motion they will come little near. Due to the inertia of motion they won't stop here, they'll come little near. It's like if you are running from here and this is the 100-meter race, rope is there. If you are running you can't stop directly here, no, you will move little apart, right? So this is the kind of inertia of motion, right? So same happens here also. So this is the reason behind the stretching and the bend and the contracting and coming going apart, and why the dipole moment is changing. In conclusion, what we should know is the dipole moment of any molecule, the dipole moment of any molecule, due to the vibration, the dipole moment continuously keeps on changing. Okay, the dipole moment continuously keeps on changing. So due to this change in the dipole moment, there will be the production of electric field in a molecule. Due to the change in the dipole moment, there will be the production of electric field. So what we come to know that all dipole moment, all dipole compound, all dipole molecule have their electric field. If anybody asks why they are having the electric field, because the dipole moment is not remaining constant, they keeps changing. Why they are changing? Because of the vibration of a molecule. Because of the vibration molecule, dipole moment is changing, and because of the change in the dipole moment, there is the production of electric field. So what so another point we'll find out here is, so in a compound with no dipole moment, no dipole, there is no charge separation. If there is no charge separation, there is no dipole moment. If there is no dipole moment, after the vibration also there will be no change in dipole moment. See, we know that each and every molecule is have each and every molecule vibrate and rotate, like the oxygen and the HCl. Oxygen also vibrate, HCl also vibrate. But because of the charge in the HCl, there is a dipole moment, and while they will vibrate they will have the electric field. But in oxygen, because of no charge separation, there will be no dipole moments. Because the no dipole moment, even after the vibration also there will be no production of electric field. So in conclusion, what we have here is a dipole moment compound, a dipole compound have electric field, while the non dipole compound have no electric field, they don't have electric field. Now we'll take an example of a matter like HCl solution is there on which the IR radiation is falling. So we should know that it's in every radiation, EMR radiation, like electromagnetic radiation, they have two field. One is electric field and another is magnetic field. And the direction of the EMR radiation, electric field and the magnetic field, these all three are proportional to each other. Suppose this is the direction in the x-axis, then the y-axis will be the electric field and z-axis will be the magnetic field. Here with this green color, I have highlighted the electric field. And inside this region, inside this wave, in this wave of the electric field, in the inside this wave, there is an electric field. This is denoted by this line is denoted by the electric field. So if I'll show it here, see here, with the movement of the wave, with the disturbance of the wave, the electric field continuously changes. See, first electric field increases, keep on increasing, then continuously decreasing and comes to zero. Again it's increasing, then decreasing comes to zero. Again it's increasing, decreasing, then comes to zero. So what we can say is, with the wave the electric field is continuously oscillating. With the wave of IR radiation, the electric field is continuously what? Oscillating. So they will oscillate at some frequency. At some frequency they will oscillate. The frequency of IR radiation is same of frequency by which the electric field of IR oscillates. I will repeat, the frequency by which the IR radiation is oscillating, or the frequency of the wave of IR, frequency of wave of IR is equal to frequency by which this electric field is oscillating. So this is same frequency by which the electric field of IR oscillates, or frequency of oscillating electric field of IR, or frequency of IR. So when the IR radiation, incident of IR radiation, incident of IR radiation, frequency of incident of IR radiation is equal to the frequency by which the molecules vibrate. Frequency by which the molecules is vibrating. There is some frequency of vibration of molecules. When the frequency of vibration of the molecule like HCl is equal to the frequency of IR, to the frequency of IR, or to the frequency by which the electric field oscillates, same, okay, or the frequency of oscillating electric field of IR, when the this frequency and this frequency matches, then there is the chance of a molecule to absorb IR. There is a chance, so they can absorb also, they can't absorb also. When they will absorb is, the molecule will absorb only if the molecule have electric field to interact with the electric field of IR. See, this is the very important point. If this molecule, suppose here we are taking the HCl polar molecule, they have some dipole moment. So due to the change in the, due to the vibration, the change in the dipole moment occurs. Due to the change in the dipole moment, the HCl is having its own electric field. We already studied dipole moment have electric field, so HCl is having here electric field. So when this frequency and this frequency matches, they will absorb only if they have electric field to interact with the electric field of IR. Here HCl is having electric field to interact with the IR, so now they will absorb. But suppose if you take the example of oxygen, if there is oxygen, then when the frequency of vibration of oxygen, so here oxygen will also vibrate, frequency of vibration of the oxygen will is equal to the frequency of IR. So IR, they don't absorb. Why? Because oxygen don't have electric field to interact with the IR. So what we studied here, the molecule will absorb IR only if the molecule have electric field. So that condition is not only enough. Suppose HCl, they are having an electric field around them, they are having the electric field, and this HCl, the bond is stretching at an 300 frequency. This example, the frequency of vibration of HCl is 300. The frequency of vibration of HCl is 300. Now if the IR is falling here, suppose the frequency of this IR is 290, frequency of this IR is 299, and frequency of the IR is 300, and frequency of this IR is 301. Then because it's having electric field doesn't mean that they will absorb all kinds of IR. No, first condition is they must have the electric field, they must have the electric field. Okay, so if they have electric field, now they'll absorb only those radiations which frequency is matching with the vibrational frequency of the molecule. See, listen carefully. So we have studied the two conditions. First condition means what? The molecule must have electric field, molecule must have electric field. Another condition is what? They will absorb not all kind of IR radiation, they'll absorb only the radiation which frequency is equal to the vibrational frequency of HCl or a molecule. So all these two conditions will help, or if these two condition matches, only the absorption of IR take place. Okay, see the last point, it's written here, leads to change in the electric field of a molecule. So after the absorption, it leads to the change in the electric field of a molecule. What does this mean is, suppose our HCl is vibrating like this. Okay, after the absorption of IR, now the energy of IR is utilized to increase the vibration of the HCl. Now it will vibrate more. The frequency of vibration is more, will be fast also, and the stretching will be also more. So now because of the increase in the frequency of vibration, the change in the moment will be also increase. The change in the moment will be also increase. Due to the change in the moment, due to the increase in the change in the moment, now the electric field produced due to the change in the moment also changes. So this is the reason behind the change in the electric field. Now coming to the rotation, as I told you before, each and every molecule vibrate and also rotate. So How they will rotate first we will know. Suppose this is the SCl. So SCl, here the what rotation means, what the chlorine will moves along with hydrogen also move, so they'll keep on rotating round and round. Here during the rotation their bond length doesn't change, this means the r radius, the value of r doesn't change. If the r doesn't change, the dipole moment magnitude also doesn't change. Then the magnitude doesn't change, but what will happen here, during the rotation the direction of the dipole moment, the direction of a dipole moment keeps on changing during the rotation. The direction keeps on changing, and we studied before the dipole moment doesn't depend only on magnitude, they depend on the direction also. So here the magnitude is not changing, but due to the change in the direction we can say there is a change in the dipole moment. Due to the change in the direction there is a change in the dipole moment. We know due to the change in the dipole moment the electric field produces. This means due to the rotation also a molecule has its electric field. So, and we know if a molecule is having the electric field, now the first criteria is done. This means they can now absorb the IR. So now when they will absorb the IR, only when the frequency of IR falling on the molecule is equal to the rotational frequency of IR. See here, rotational frequency of IR. Okay, there if the frequency of IR matches with the vibration, then they will absorb and the vibration frequency will increase. Okay, but if the rotational frequency of IR, see they are rotating with some frequency. Okay, if this rotational frequency of a molecule matches with the frequency of IR, then the rotation frequency will be increase. Before, this means suppose a molecule is rotating with this frequency. Now if the IR radiation with the frequency, suppose 350, with the 350 frequency of IR falls on the this molecule which is having the rotational frequency 350, now what will happen, this molecule, because of the rotation there is the change in the dipole moment. Due to the change in the dipole moment the molecule have the electric field. So the electric field, when the IR radiation of same frequency of the rotational frequency fall on the molecule, now they will absorb because they have the electric field to interact with the electric field of the IR. So when they absorb, the energy of IR is used to increase the frequency of a rotation. Now before, if its rotation frequency is this much, now what will happen, after the absorption of IR the frequency of rotation will increase. So when the rotational frequency increases, the change in the dipole moment also increases. So due to the increase in the change in the dipole moment, electric field also what increases. So there is the change in the electric field, there is the change in the dipole moment. See, before the irradiation of IR, before the falling of IR, due to the falling of the IR, there is the particular change in dipole moment, and there is the particular electric field. This is fixed. Change is also fixed, electric field is also fixed. But after the falling of IR, what is happening? The change in dipole moment is now increases. The change in the dipole moment increases. Due to this, the electric field also increases. So this IR radiation is affecting the dipole moment of a molecule and affecting the electric field of a molecule, affecting the electric dipole of a molecule. So in conclusion, what we should know, due to the vibration, also dipole moment of a molecule changes, electric field produces. Due to the rotation also dipole moment changes, electric field produces. Because of the vibration and rotation, they have the electric field to interact with the electric field of the IR. And coming to the non-dipole compound like the oxygen, nitrogen dioxide, because they don't have dipole moment, because of the vibration and rotation also there is no change in the dipole moment, so no production of the electric field. Now here you see, as I told you before, only vibration requires higher energy, and this is provided by near and the mid IR, while the rotational, for the change in the rotation they require less energy, which is provided by far IR compared to near and mid 5 IR has less energy, and microwave, which is having less energy than IR radiation. Coming to the summary, the criteria for a compound to absorb the IR radiation. This is, you should have this one, you have to write in the exam. The criteria for a compound to absorb the IR radiation is, first one is correct wavelength of the radiation. Correct wavelength means what? If the if a vibrational or the rotational, suppose the rotational frequency of a molecule is 300, then on falling of 250 frequency of radiation or 299 frequency of radiation, the absorption doesn't take place. Exactly same 300, if the rotational frequency is 300, then the IR radiation should be also of 300. If the vibrational frequency of 250, then the IR radiation should be also 350 for the absorption. This is all about the correct wavelength. Natural frequency, vibration or the rotational frequency of some part of a molecule, same frequency of the IR or the oscillating electric field, then only the molecule absorbs the IR radiation. Second is what? Change in the dipole moment. This means what? Already they have some dipole moment, they are changing. Now after the falling of the IR radiation, if after the absorption, if there is a chance of change in the electric field, see, already we told the SCl, they are having its own electric field due to the change in dipole moment, due to the vibration they have, due to the rotation they have its own electric field. So after the falling of IR radiation, if because of absorption, if their electric field changes, then only, if there is chance of change in the electric field, then only what will happen, then only the absorption take place. If there is no chance in change in the electric field, then the absorption doesn't take place. Like in the oxygen, they don't have electric field. So if the their vibration frequency is 300 and the falling radiation is also 300, so matching this condition is not enough. They must, they must have electric field. Why? Because if they absorb, there should be some change in the electric field. If they don't have electric field, then what change will occur? So because of no electric field, there will be no absorption. Because of electric field in SCl, after the absorption there can be the change, there is the possibility of the change in the electric field. So that's why the absorption take place. So this is all about the criteria for the absorption of the higher radiation. You can take the screenshot of this. Thank you, class.